All right, so welcome everybody to MIT Lincoln Laboratory Science on Saturday. I am so grateful that you are here to join us. So next slide, please. I want to talk about a little bit of the show logistics. As you can see, you guys are all muted, but there may be a time where you will be unmuted to answer ask any questions you may have. If you have any questions, type it in the Q&A tab at the bottom of your screen. But before we do that, can you type hi to me? If you've ever been to a Science Saturday in our auditorium, you know how much noise I love. I like everybody to shout out hi, hello. But in the chat, why don't you say hi and tell me where you're from? And we'll keep going as you're doing that. Hey, Arlington. Hey, thank you. I'm glad you guys are joining us. So there may be a point in the presentation where our panelists will ask a question. You may use the raise hand feature, and you will be unmuted to ask your question or answer the question. At the end of the show, as you can see, it is being recorded, and we will post this recording on our website at www.ll.mit.edu/outreach with this show. So you can go back and watch it again if there's anything you did not understand or you want to share it with other friends. Okay, with that, next slide. So our panelists, our speakers today are Alan Hsu and Larry Kandel, and they are going to talk a little bit about the things you've been hearing about over the past 10 months about COVID. So with that, Alan, take it away.
All right, thank you very much. I appreciate the introduction. Let me try to share my slides. All right, so let's just get started. I'm going to talk to you today about wide area fever screening. And my goals for today are, one, I want to teach you something new about science and cool technology. Who doesn't like that? Because I know this is Saturday, and this is a very important time for you kids, especially. Two, I want to ask you some questions, and I want to have you answer back as loudly into your screen as possible. You know, before they did this in an auditorium, kids were yelling at the speakers. I want the same kind of energy. Just to show how smart you are, you can show your parents too. So I think that'll be fun. So, and lastly, have fun. So let's do that. Question number one. This is an easy one. What is this girl wearing on her head? I think you guys know. Shout it out back to me. Go ahead. Yes, that's right. A face mask. That's easy. Okay, you guys are good. Let's try number two. What is this a picture of? This is a little trick here. People are standing around. Shout it out to me. If you don't know, you could ask your parent. Okay, I was looking for social distancing. This is where you have to stand 6 feet apart so you don't spread COVID, right? Number three, there's a little trick here. What is happening here? There's a woman, she's relaxing in a chair. Oh, she looks like she's getting something done on her arm. Shout it out to me. What's going on here? Okay, yes, she's getting a shot. And moreover, this is a COVID vaccine shot 4 days ago in the United Kingdom. They now have the COVID vaccine. This is great news. So I think we can all agree, yes, this is fantastic. Number four, what is this thing? Huh? Have you seen this thing before? Is it a laser blast or something? Shout it out to me. What is this? It's got a number on it, 98.3. Yeah, yes, it's a thermometer. Yes. So this is what I'm going to be talking to you about today, okay? And it's a good point to point out that when we get this number on there, this is your temperature that's being estimated. Normal, healthy temperatures are kind of in the range of 95 to 99 degrees Fahrenheit. And if you see something, a number around 100.3 or higher, the Center for Disease Control says that's a fever. So at that point, you should probably stay home. But just so you know, that's kind of how it's defined in that way. So last question, what do all of these things help with? We talked about the face masks, the social distancing, the vaccine, the thermometer for fever screening. Shout it out to me. What do these things help with? Yes, stopping COVID from spreading. So I think we can all agree that's important. So moving on. So we got the thermometer. It's great. It helps us screen for fevers. One of the problems is it takes 5 to 10 seconds per person. If you've seen this thing in action, you know, you got to kind of point the thing at the person's head, you press a button, click, get a reading. And if it's busy in the morning, let's say your school or you got to get into work, there'll be a lot of people piling up. People are standing in line. And hey, it's wintertime. So waiting in line on cold mornings, that gets the thumbs down emoji. So can we do better? Yes, I think we can. What I'll talk to you today is some of the cool technology that we're working on at MIT Lincoln Lab and how it works. So I'll tell you more about this thing, but what it's going to do is, one, measure everyone's temperature over a wide area instantly, so you don't have to wait around. So I think we can all agree, not waiting in line gets the thumbs up emoji. And furthermore, what this thing can help you with is measuring, screening for fever in big crowds, like airports. There's a lot of people. Outdoor events, in this case, people are protesting, in this case, climate change, but there's a lot of people getting together. If someone has a fever, you know, COVID could spread around. That's not good. So if we could screen for fever in these big crowded places in wide areas, that's also a good thing for public safety. So another reason why this could be useful. So first, I'll talk about how does this thermometer work, okay? And it's actually in itself a really cool piece of technology. So we'll start with some science facts, okay? All objects, you know, your hand, your toys, they emit light particles called photons, okay? Which is pretty cool. You may not have known that. The second thing is the color or the wavelength, but we can think about it as color, and the rate, meaning the number of these photons that are coming off, let's say your hand or your, you know, your eyes or this headphone. The color and the rate depends on the temperature of the object, okay? So that's interesting. What are some examples of this? I'm thinking the first example is, what is a really hot thing in the sky? It's really hot. You look at it, you kind of squint your eyes, and it's got some color. Yell it out to me. What is it? Yes, it's the sun. Yes, that's right. So it's really hot, obviously, it's the sun. The temperature of the sun is about 10,000 degrees Fahrenheit. We talked about you being about 98, 100 degrees Fahrenheit. The sun's 10,000 degrees Fahrenheit. It's really hot, and it's got this color of kind of white yellow, okay? So that's one example. Another example is something I'm thinking of comes out of volcanoes. Yell to me. It's hot, it's red, gooey. What am I talking about? Yes, lava. So this is a picture of lava at night. It's so hot, it's glowing, kind of more of a reddish color. That's 2,000 degrees Fahrenheit, and it's red. Okay, so two examples of things that have in this case, a really hot temperature and are glowing. So, you know, here are shown those two examples that I just talked about, sun and lava. Another cool example is forged steel. Steel is really hard to bend, and if you need to bend it, you need to heat it up really hot. And so people who work with this, they bend it according to the temperature, which they can tell by the color. Okay, if it's really white, hot, yellow, you can see there it's 2,400 degrees Fahrenheit. If it cools down a little to the right there in that middle picture, it turns more of a darkish red. In this case, 1,400 degrees Fahrenheit. So in this case, very hot objects emit visible light. You can see this with your eyes. You can see this, and you can see this with things like your phone camera. Now, for cooler things, as we see that big arrow, we're going to decreasing temperature. Those less hot objects emit invisible photons. You can't see them with your eyes, and what we call those infrared photons. You notice how these that steel was kind of darkish red at the cooler. This is in the far red or infrared light photons. So they're invisible, but we can see these with special infrared detectors and cameras. Okay, which is nice. So let's see. So how does this thermometer work? I said everything is emitting photons. Since we're 100 degrees Fahrenheit, a little cooler than lava, these photons are invisible. They're infrared, okay? So the thermometer, what it uses is an infrared detector. Hey, that makes sense. That little detector, it's like a little disc, that orange thing, converts those photons to electrons, okay, little charges, and that generates an electrical signal in this device. And depending how big it is, then you get a temperature reading, in this case, 98.3. So if this person's hotter, she'd emit more photons. That detector would make more electrons. You get a bigger electrical signal, and then you get a higher temperature reading. So that's generally how it works. So how does the thermal camera work? Okay, let's say we want to take an image of somebody's heat or temperature. So for a camera, you can stand farther back. And the camera usually have a lens, this blue thing here. That helps collect what you're looking at, focuses the light, and in this case, instead of one detector, like in the IR thermometer, we're gonna put it on an array, a whole bunch of them, right? Kind of spread out in this kind of grid pattern, okay? And let's pretend, you know, I have 25 drawn here. Let's say we have 100, and they all have different values depending on the temperature and the electrical signal in the scene. And so you might get an image like on the bottom right. Let's say white is a higher value or hotter, dark is a cooler value or colder. Still kind of grainy, okay? 100 pixel image. So how do we make this image look better? More pixels, right? Forget 100 pixels, let's do 1,000,000 pixels, okay? And if we do that, we have more pixels, we get a better resolution image. And on the bottom right, you can see more clearly who this is. You kids may not know who that is. Your parents might, but so now you can see kind of who this is. That's great, okay? So in general, more pixels, better resolution. We can kind of see what we're looking at better. So that's helpful. So now I'll move into a kind of a thermal imaging demo. What are these thermal cameras in the infrared help you with and do? So let me try to do that. I'm going to stop my share, pause share. So now I am actually not at home. I'm actually at a building at MIT Lincoln Lab. And the reason why I'm here is because in one of these buildings, we've got one of these thermal cameras. I don't know if you can see that, that little guy over here on a tripod is looking down at me, okay? And so that's looking at me, and set up, connected to that camera is a computer, and hopefully you can see that, of me in the thermal kind of infrared regime here, okay? So can you see that? Okay, so some interesting things about that you notice kind of my face, you know, it looks like it's kind of a, and I apologize for the blinking, the orange means hotter, the blue, dark blue, means colder. So you can see on my face here, and there's a little bit of a lag, but the orange is warmer, and you notice my hair, my nose, my ears, and my clothes are cooler, okay? So those are some, really this is not measuring what you're seeing here on this side here, measuring the infrared side. This is the heat coming off me because we're measuring infrared invisible light with the special thermal camera. So some examples of that, okay, let me see if we can do this. Okay, I've got something in this bottle, okay? And I said red is hot, dark blue is cold. Can you tell what this is? You can probably tell from the picture too. Is that hot or cold? Just yell it at me. Yeah, it's cold. That's right. It's ice water. You can kind of see the ice cubes, so that's not that interesting, maybe. And you see, kind of compared to my arm, right? It's quite a bit colder. One of the other cool things about thermal imaging is you can in thermal imaging you can kind of see through things that you can't see through in normal cameras. So here's this trash bag. Okay, you can't see through what's inside with a normal camera, but with the thermal infrared, let's say if I stick my arm in there, you can kind of see through the bag with the thermal camera, but you can't see it through it, the visible camera, okay? So these are some of the cool properties of this infrared thermal imaging that you don't have with the visible imaging. So I just thought that would be cool to show you guys kind of in person. All right, so let me just go back to the rest of the talk. Let me share, and you know, I'm sure there are a lot of questions. Just love to have them at the end. Okay, so let me try to share again. So we just talked about this detector array. We actually make some of these infrared detector arrays, or you can call them a focal plane array here at Lincoln. And of course, since we're MIT and Lincoln, we don't just make the normal ones. We make kind of smart versions of them that can do more than the average ones that you can buy. So, and I'll talk a little bit about that in a little bit, but we can put these in cameras like this one on the left here. This big kind of complex looking thing is the camera, okay? So we stick this infrared focal plane array in where this blue box is, okay? And then you attach a lens to it like you kind of do with a camera. And then you can see stuff. You can make images, like you take pictures like you do with a camera. And this lens kind of defines the field of view, or kind of the angle at which you're looking at stuff, okay? So this was made here at the Lincoln on another project. And so what did we do with this thing? first, we wanted to learn more about how thermal images of people relate to the thermometer readings that we're trying to really get accurate estimates of. Because again, the goal is we don't want to stick this IR thermometer on everybody's head and wait in line. We want to just take images of you and try to get an estimate of your temperature that way. So the first thing is learn about how this looks and works. So the first thing we did was we took thermal images of a lot of really nice volunteers who came in and said, yep, we'd like to help, please, how can we help? So what we did, we took our MIT thermal imaging camera here, shown here in this blue box, and we had taken thermal images of volunteers. So this is Tom. He works with me in our group, and we take thermal images. And here's an example of Tom in the thermal image. And kind of like maybe if you notice in my picture, in the thermal regime, again, looking at the heat coming from you, certain things look different from a normal picture. Normally, you know, inside your eyes looks warmer, your hair looks cooler, and you know, your forehead and around this heat area is related to how kind of veins and arteries run through your head. If there's veins and arteries around your head, those areas look warmer because there's blood flowing. And the things that are cooler, like your nose, your ears, those don't have as much blood flowing through those. So those tend to look colder, and then your clothes are even colder. So we would take lots of thermal images of people. We'd also take their actual thermometer measurement, and that's, to us, are the truth reading of, hey, we took an image, but his temperature is really this, and this is the kind that goes on your forehead. And then, so from all this, and this is like hundreds of very nice people who did this for us, we would make an imaging processing predictor. Okay, the goal is that we take in this image and we think about it, do some math, and we come out with our guess or estimate of the temperature. In this case, this is a pretend example, 98.4 degrees Fahrenheit. Okay, I'm guessing just from this image, I think his temperature is 98.4. And let's say the thermometer said is 98.2. That's pretty close. So that would be a good prediction of his temperature. Okay, so maybe we could do a really good job for Tom. The problem is we have to take this for a lot of people. Here's some more images. You can see how for all these different people, their thermal images on the bottom can look quite a bit different, okay? Some people have colder noses, like the guy in the middle, the fifth guy, the sixth guy, they have colder noses. Some guys have warmer kind of mouth or forehead. Everyone looks a little bit different thermally, and that could be the case even if they have the same thermometer temperature. So it can be a little bit tricky to do this accurately, so and which is the goal. In any case, I think we figured out some good ways to do that. So what we decided to do is, hey, let's test this thing in the lobby, okay? So this is our camera. I also mentioned we wanted to do this over a wide area, and I haven't really talked about how we would plan on doing that. So to give you an example, one thing that we could do to scan over a wider area is to move the camera, okay? So I'm just gonna lift up my laptop camera. Hey, let's go look over here. Oh, that's a wide area. Let's look over here. Okay, we're covering a wider area because we're moving the camera around. Okay, that's one way to do it. Problem is these things are kind of delicate. You don't want to shake them around. So the other way to do it is put it in front of a mirror, okay? Okay, so now you're looking over the side. If I move the mirror around, okay, I can scan it and look over a wider area that way too. My camera is kind of staying still, but my mirror moves around. That's great. So I can do it that way too. So that's the way we decided to do it here, okay? There's the camera, and next to it is this spinning polygon mirror. So this thing does kind of what I just showed. It scans a scene, a wider scene across the camera, and our smart camera can pick that up and make a nice image. So we took this down to the lobby, okay? This is our lobby. On the right, top right is kind of where people come in and they go into this lobby, and then that's toward the bottom they go to work. But it's sitting here, it's looking out toward this green square, okay? And the idea is, hey, can we scan people as they walk through the door, okay? So this is what some of our first pictures here. On the bottom is a thermal image. Again, the doors where you're coming out to the right, people are walking in to go to work. So if we didn't do this scanning thing with the mirror and the smart sensor, the field of view that we'd have is kind of this rectangle on the left here, where we catch the guy just on the left. And it's not a wide enough field of view to be really useful in this application. But if we couple with the spinning mirror, what we get is this full wide view, okay? So we stitched it together with our smart sensor. Oh, this is great. We got a wide area, and this is really interesting imagery too, because you can see, you can kind of get the thermal images of these folks. Also, hot things are like hot cups of coffee here that happen. And those are obviously also hot, so they show up hot. So here's a good initial image when we're doing the testing. So over the course of developing this was when COVID hit late April or late March, right? Late March, and everything shut down. MIT asked us to, hey, can we build this wide area fever screening timeline? So we were very busy over the course of March and April doing this lab testing with nice volunteers that I talked about, building up the sensor system, working on the image processing to figure out how to go from image to an accurate temperature estimate, and then fielding it in the lobby. So that's kind of where we're at now. So here's a video of the system, and I'll just go through. This is actually hosted on the upper floor above the lobby, so we get a good vantage point. And I'll just play this video. You can see what this looks like. So play. Let me see. I just wanted to share my audio. So what I'm showing is a picture of the system with the spinning polygon mirror looking down at the lobby. And it's, again, using that smart thermal sensor and that spinning polygon mirror to kind of get you that wide area. On the top left is that visible camera. It kind of gives us a normal looking image on the top so that people can see that as well. So that's helpful. So this is running in real time in the lobby now, okay? And then I'll show you another video. So this is me downstairs where security usually sits and looks at people's temperatures. In this instance, I happen to be sitting there, and let's just see what happens.
Action. Hey Dave, how you doing?
Good, Alan. How are you?
Good. Hey, you know what? We're doing this temperature monitoring thing here in the lobby of Lincoln Lab. All right, let's see how you look. I have you on the screen here. All right, 98.4. Okay, looking good and healthy. I'm glad to see you don't have a fever.
Thank you very much.
It's good to see you. Yeah, you too. All right. Oh, there's another guy. No, Yorgo. Yorgo, how you doing?
How are you?
Hey, good. All right, let's see how you're doing today. Uh-oh. Wait a second. I see a big red. Whoa. 106.6 degrees. Are you feeling okay, Yorgo?
I don't know, I'm a little hot out.
What? Wait a second. What's that on your head?
Oh, this
Yeah.
is my fever patch.
Oh, fever. Oh, you forgot you left your fever patch on. We use that for testing the system because people usually don't come in here with a fever. Okay. You're probably okay then.
Okay, thanks.
All right. Yep. See ya. Bye.
Okay, so as you can tell, that was a little bit staged, but it's just a demonstrative thing of how the system works. So that's really it. What have we learned today? Just to wrap it up, fever, as you all know, is one symptom of COVID, and fever screening with the system, a thermometer or what we built, is one way to help stop the spread of COVID. Sorry. So objects also, from a science point of view, we learned that they can emit different color, visible or invisible photons or light particles depending on their temperature. So some examples were the sun, lava, you, right? You're emitting invisible infrared photons, right? So we can use special detectors that can see invisible infrared light and estimate your temperature. And we talked about the IR thermometer, which is like a one detector, one pixel thing, and the thermal camera, which you can get lots of pixels and nice images. So, and lastly, we built and operate a special thermal camera system to cover wide things like the lobby, uses this image processing to do a temperature estimate. And importantly, you don't have to wait in line, right? I know, especially you kids, time is important. So I know you don't like to do that. So that's all I had. I just wanted to thank to end the many people at Lincoln and on our groups who helped build, test, and operate the lobby system, to the many volunteers who helped us learn about thermal images and temperatures with their time, to Healthy Dave and Fever Patch Yorgo in that short video for their stellar performances, to MIT and the PALS committee, the folks who are hosting this, for hosting this webinar, And most of all, to you kids and parents for listening. I know it's a Saturday, so thank you. Have a great day.
Okay, thank you, Alan, so much. We really appreciate your presentation, and we've
All right.
learned a lot about thermal imaging. So next, we are going to move on to Larry.